Alright, so we got a cell right here, and it's made of these two sides. This is one chamber, that's the other chamber. We will put O-rings into both sides. And then we'll put a sample in between, and then we'll fill it going through one of these holes and then coming out on the other side. The way that we assemble these cells is these rods are guide rods. So, gotta put it together like this. Alright. Okay, so these are guide rods which help you when you assemble it, that you can put the sample together without any lateral movement, because lateral movement could break your device. So once you've assembled it like this, you add the screws to it and you screw it tight, and then you're in business. So first we gotta clean this. We also want to make sure that there's no air bubbles trapped. In order to do that properly, we want to make sure that we flush it. So I'm going to use this one, and I'll use that to flush out any kind of bubbles. You'll see that it's being forced out. Now there's going to be bubbles trapped in the channels, so in order to get that out, you really need to stick this end of the pipette in, and then you blow it. And you saw that those bubbles were coming out, so indeed there was air trapped in there. And I'm going to do the same thing on this guy. You see there were air bubbles trapped in there as well. Okay, and now I'm going to do the same thing on this guy, this side. So flush it. And then the other side. Okay, now if you want, you can sonicate it and really clean it very, very, very thoroughly, but this is just a test, so that's not needed. You want to make sure that once it's clean and it's dry, before you assemble it, you dry it off properly. So I'm going to now pull out this cell and I'm going to dry it. All right. And we'll use the air for that. Oh, sorry, air. And of course, now we've got water trapped here in these channels, so we want to remove those. They're just kind of like, they're like this. Some droplets trapped in there. All right, that's one. Okay, so this is a blank wafer. It's nicely hydrophilic, and you can tell because when you pull it out, see how thin that capillary is of the water. The water film is very thin, and you want it to be that thin because otherwise you're going to have trapped air. Now, if I'm going to assemble it like this, this water will wick onto the side, and it could cause shorts. So I actually want to dry this and have it in the cell. Alright, so now this is dry. Now I'm going to be assembling the cell. So take an O-ring. That's one. Close enough. Okay. Now, these are the guide rods again. You want to make sure that the flat pieces are going to be on the same side. Okay, so I'm going to stick the sample in. Now this is a blank wafer, so it doesn't really matter exactly where we put it, as long as the it's completely covering that O-ring chamber. So now I'll just close it and add the screws. 1, 2. Once the screws are in, you can pull out those guide rods because you know, they could be causing shorts if you do have some kind of a water film. But then again, you also have these screws there, so yeah, you can remove them if you want to. Okay, so that's the way it assembles. You can see it's all dry, and that's important. You don't need to tighten it that much. I usually tighten it maybe like half a turn more. That should be sufficient. And now the next step is to actually fill this thing with salt water. So we've got the salt water here. Usually you want to use a different tip for this, but this is just a demonstration. So, yep. All right. So this is salt water. It's KCl, 1 molar. You see, there's a bit of air trapped on the edge. I want to make sure that there's no air, so in there. Make sure it's flushed. Now the other side. So both sides are wet now. What you want to look for is you want to make sure that in this gap here there's no liquid trap, because if there's any kind of liquid trapped here, that could cause a short. So you could use a napkin. Got a napkin. You use a napkin to make sure that there's no air, no water trapped, and also to verify that if it's there, to kind of dry it off. So it's bone dry, there's no liquid that came off. Okay, so that's good. So next step is we're going to mount it in the setup. Okay, so now we got the cell together. The sides, they're both wet. Both sides are wet here. And we're mounting it here. This is just a test setup to see what the resistance looks like and make sure that we got no shorts. This is going to pick up quite a lot of electromagnetic interference, but that's okay because it's sitting outside and we just want to verify that everything is working correctly. So this is the current amplifier side and this is the voltage driving side. These two electrodes, they're silver chloride electrodes. They're basically what happens to silver wires if you stick them in bleach. The first thing I'd like to do is turn it on, obviously, is to test whether the setup actually works by sticking these two electrodes on the same side. Usually it takes a little bit of fidgeting. Okay, now we're going to drive a voltage from this connector to this pin through the silver chloride wire, through the salt water, so changing the silver chloride to chloride, then going here, the Cl goes there, becomes silver chloride again, current goes through the silver wire into this probe, there's a 10 meg resistor here in series, and then it goes out to the computer again. So we'll measure, because this is pretty much a short, we'll measure about 10 mega ohms here. Okay. Okay, so you want to be in this this part of the wherever you have the data acquisition software, we have a branch called Dev2, which is where we are working currently. There's one program called XY, which will do an X scan and measure a Y signal. Alright, so this is just a test, so we'll set this to auto hide. The voltage driving side, so the X signal here, it has no amplification, so it's just multiplied by 1. Units are volts, that's the bias. The Y side, it's got a current amplifier. It's going to end up with something in amps after you multiply it by this factor. So that's the Y amplification. We're going to sweep from minus 0.2 volts to 0.2 volts in steps of 1 millivolt. We're going to go at half a volt a second, so it's going to go pretty fast. Now this should be a short, so run it. Yeah, sure enough, it's a short. The resistance here is 10 megs, a little over 10 megs. You see the data is scattered around the straight line a little bit, but at least the slope is 10 megs, so that's what we expect. And now we know that the setup is working correctly, so now right after we're going to go here and we'll stick the other electrode on the other side. Make sure that the electrode goes in the water. So now the only way to complete the circuit would be to go through that wafer, and if all goes well, this is going to be an open circuit. So we'll go here. I leave this guy up for reference just to keep an eye on it, and then hit start. Yeah, sure enough, that's an open circuit. Resistance here, well, what is it? 1, 2, 3, yeah, 500 mega ohms. Yeah, something like that. Anyway, plenty.